Okay, so we're just going to do a few more pages in the notes, so just bear with me. Um, so we're going to work with just the next page, so flip your page in your notes, and we're going to look at graphing linear relations. Okay, so this is all still review, so this should be at least vaguely familiar. Well, we're in Math 11, we're going to look again at graphs of linear relations. So this is a pretty important part of math. It comes up basically from like grade 6 or 7 all the way up to grade 12. We will also explore systems of linear relations. Okay, so that's something you might not have seen before. And another thing that we're going to work with are linear inequalities. So this is like you draw it the same way as a line, but it tells you different information in a graph. So remember how we talked about how the brackets, so this bracket and this, or I guess these brackets and this and these all sort of mean the same thing? It's the same sort of idea. So on the very first day we talked about the equation for a line. And remember that we said it was y equals mx plus b. And we'll talk about what all that means, so don't worry about that. So that would be something like this, right? Y equals 2x plus 3. And that's what you would have been working with before. But now we're going to work with y is greater than or equal to 2x plus 3. So this would be what you would see in Math 10 or Math 6, 7 if you were in that. And this would be like a Math 11 sort of thing. So the only difference here is that we have this inequality instead of an equal sign. Okay, and it will not always be greater than or equal to. It will change depending on what our graph says. So first of all, before we start graphing lines, we need to be able to read coordinates off a graph. And so we worked on that a little bit last week. We need to be able to find slope. That's super important. So slope will be your friend, okay? So if at any point you're struggling with slope, that's something I want you to come talk to me about, okay? Because slope is so integral to this section, and I really want you guys to do well. And then we'll learn how to graph a linear relation. So let's start simple. How to read coordinates off a graph. So remember that coordinates are always given in the general form of, what are they? Tell me. X, Y. Okay, the x value should always come first and then the y value. So if we look down here at this graph, and again this would be a great point for you to pause the video, try to fill out all the coordinates over here, and then come back to the video and see if you got them right. So if I look at A in my x, I go over 3, 1, 2, 3, and up 1, 2, 3, 4, 5, 6, 7. So 3, 7 is my point there. At B, my point is 5, 4. And please, like I said before, feel free to write all over your graph, okay? If you can't look at it and eyeball what it is, write on it. Just go, okay, so I start here, I go down to 5, and I go over to 4. Okay, these are your notes, so just write all over them, whatever it takes, whatever you need to see what's going on. In this one, on my x-axis, I go to -3. But I don't go up or down on my y, so that becomes 0. D, I go to the left -4 for x, and I go down -4, so my point is -4, 4, sorry, -4, -4. And then E, I go over 2 to my x, and I go down -2. Okay, so this is a really important skill. And when I ask for coordinates at any time, that's all I'm asking for. So coordinates never get complicated or tricky in any way. The big thing that you need to be remembering is that it should always be x, y, okay? Always. And this is important because when we start graphing our linear inequalities, I'm going to ask you to pick out coordinates that are either included or not included in the data. And again, all I ever want you to do is then find me points that count, but you need to be able to write them in that proper manner. Okay, so that's reading coordinates off a graph. Then we have to look at, again, this is just another way of reading the graph, making sure we understand what the graph is really saying. So the origin and the 4 quadrants. The origin of a graph, of any graph is the center of it, 0.00, okay? So 0 for x and 0 for y. That is your origin. That's what we call that. And then we have the x-axis and the y-axis. And these two axes divide what we call the Cartesian plane. That's just a math word for saying graph, okay? Because a graph could technically just be like a page of graph paper, which does not have x or y axes. And so when we have them like this cross shape, that's the Cartesian plane. And so the Cartesian plane, because it's a cross, naturally breaks us into 4 quadrants. So quadrant meaning 4, okay? And we number these quadrants in a counterclockwise order. And this is the accepted way to do this. Don't make up your own order. Again, this is one of those things that you should be able to go to like Belarus, if that's still a country, and they should be numbering their Cartesian plane in the exact same way. Okay, so you have 1, 2, 3, and 4. And they're always numbered using the Roman numerals. I don't know if that's a huge deal, but that's how you're always going to see them. And these are the easy Roman numerals, so they shouldn't be that difficult for you to remember. So the other thing that we have to look at, so we have our origin there. That's 0, 0. The important thing about the quadrants is to think about, if I have a coordinate in a quadrant, what is it going to be in terms of signs? So in quadrant 1, all my x values are what? Positive or negative? All my x values are positive, and all my y values are also positive. So any point in quadrant 1 is positive, positive. And that's good. That's something we're going to need to remember, because that's where things like whole numbers and natural numbers will be found. Okay, so if I ever ask you, give me a coordinate for a whole number, you can't ever be in any of the other quadrants. You have to be in quadrant 1. Then in quadrant 2, my x this time, my x's are all negative, but my y's are still positive. Okay? Down in quadrant 3, again, feel free to pause the video and try quadrant 3 and 4 by yourself. My x in quadrant 3 is negative. And my y is also negative. Okay, so quadrant 1 is 2 positives, and quadrant 3 is 2 negatives. Okay, and then quadrant 4, my x is positive again, my y is still negative. So, knowing how the quadrant works, knowing where the signs are, if we are given any ordered pair or any coordinate, we should be able to say which quadrants it's in without even plotting the point. So remember, we have quadrant 1 is positive, positive. Quadrant 2 is, negative, positive. Quadrant 3 is negative, negative. And quadrant 4 is positive, negative. So let's look. 3, 8. My x is positive, my y is positive. That's got to be quadrant 1. Negative 1, negative 1. My x is negative and my y is negative. Both are negative in quadrant 3. Negative 3 and positive 10. So my x is negative, which means I'll be moving left on the graph, but my y is positive, so I'm moving up, and that gives me quadrant 2. And then the last one, 10, negative 3. So my x is positive, so I'm going to be moving right. My y is negative, which means I'm moving down, so I have quadrant 4. Okay? So that's the origin and the quadrants, and we just kind of have to know these words because when we move on, these are assumptions. Okay? So let's just look at this last page and then we'll be done for this week. So restrictions. If we look at the domain and range, we can see if there are restrictions on the possible values of y and x and y. Okay, so there's all sorts of restrictions. It's going to be things like what kind of number are they? So is it a real number, a whole number, an integer? So is it continuous or discrete? We can also see when they're plotted with inequalities where our limits are. Okay. So here's an example of, I have my curly brackets. This is set notation. This one's a little different than what we were working with. So take a minute to look at it. What's different? If you notice here, it's got x comma y. That means it's showing the domain and range together. And with a line, because a line includes y and x, we can do that. Okay? So x and y, or xy such that y equals 2x plus 2, and x belongs to all whole numbers, y belongs to all whole numbers. So this is whole numbers. And whole numbers, remember, are 0, 1, 2, 3, etc. Which means which quadrant do I have to be in? If x and y are all whole numbers, that means I cannot go into negative numbers at all, which means I have to be in quadrant 1, because x and y can only be whole, which is another way to say positive numbers. Okay, so when we work with real world problems, and inequalities are used in real world problems, this is where we normally live, right? And so because we have whole numbers or natural numbers, right? So if I'm counting, how many houses can we build in this area or something like that, it has to be a whole number or a natural number. So if I'm counting people, things like census or animals, those all have to be whole or natural numbers. And so whole and natural numbers are restricted to quadrant 1. Okay, so anytime you have a whole or a natural number, you're going to stay in quadrant 1 all the time. So if I look at this next one, again, I have domain and range together because I have a line, so that's okay. But I look at my restrictions, x equals, or belongs to all real numbers, y belongs to all real numbers. Remember that real numbers are continuous, it can be positive or negative, it can be a fraction or a decimal. So do we have any restrictions here? Any quadrant that we can't go into? No. There is no restriction because x and y are all real numbers. So we're lucky, we don't have restrictions here. And we're not given any other restrictions, so we're not given an inequality at all. So if you're given something with all real numbers and you draw this line out, and here's your graph, then your line can just go in any direction. Okay, so that's all we're going to do today. So there were 2 videos. So if you did not watch 2 videos, go find another video to watch. The set notation worksheet is not due, okay? Do it. I want you to do it for practice, but you're not handing it in. The continuous and discrete data worksheet, which you should have, and if you don't have it, you can pull it off the internet, is due on Tuesday. And also on Tuesday, you will have a quiz. I am going to make this quiz shorter because you will write it alone. And the things you should know for this quiz are things like, sorry, let me grab my other thing of notes. Domain and range, interval notation, set notation, and maybe there will be one question on just the very basics of continuous and discrete data. So like I might show you 2 examples and say what is continuous and what is discrete, just like we did on the review. Okay, so your main concern for the quiz, domain and range, and being able to put those into your inequalities interval notation, and set notation. So basically the notes that we did last week and on Tuesday. Okay, so really up to page 8 in the notes, and then just be aware in page 9 and 10, okay, of the difference between continuous and discrete data. If you have any questions, please email me, or you can come see me on Monday if you're in the school. Okay, so have a great weekend, and I'll see you next week.